solve another Leetcode problem, 105. Construct binary tree from preorder and inorder traversal. So if we are only giving a preorder traversal, so we cannot construct the binary tree, because it can have different combinations. But if we have the preorder and inorder traversal together, and you need to check the constraints, and basically it should be like this. The preorder and inorder should always consist of unique values, and its value of inorder also appears in preorder, and preorder is guaranteed to be the preorder traversal, and inorder is guaranteed to be the inorder traversal. And those lines are really important for us to solve the problem, otherwise we cannot solve it. So the idea is that we are given two arrays. So one array is the preorder traversal of the tree, another is inorder traversal of the tree. So we're gonna use the array. We're gonna use the array to basically to solve the problem. We're gonna use the two arrays to build a tree. So we're gonna use the tree traversal to solve the problem. So we're gonna define a DFS function. Yeah, and after that, we're gonna return the DFS function. So inside, we're gonna have two arrays, preorder and inorder. Yeah. Now we want to write a DFS to realize this kind of configuration. Basically, we need some mathematical calculation. We need to understand what is the first node, this node 3. Can we find it easily? Yes, if we have a preorder array, definitely we're gonna find the root of the tree. It's gonna be the first index. It's gonna be index 0. It means this is 3. Gonna always be the root of the tree. So from here, we can write the root of the tree. But we have to check if not preorder. This means if the preorder array is empty, we're gonna return a none. Yeah, so this is just for at the end. For example, for this node 9, at the end, the preorder is empty, so we're gonna return a none at the left and right side. Yeah. Now, as I explained, definitely we can find a node. Yeah. So this node, from the beginning, it's gonna be the root of the tree. So it's gonna be a tree node. So we configure a tree node. Inside, it's gonna be preorder 0. If we find a node, then we're gonna find what is the node left and what is the node right. If we can find, so for example, node left gonna be DFS something, and node right gonna be DFS something. Finally, we just need to return this node. Yeah, because this node definitely gonna be the root of the tree. Yeah, and we're gonna build it recursively like this. So the problem is that how can we find the left side and the right side? Now we just need some calculations. So for example, if we find the first node gonna be this 3, then how can we find which node are at the left side and which node are which node are at the right side? So we're gonna use this number 3. So from the inorder array, we're gonna use index to find its index. Now, if we find the index, for example, the index is 1. So at the left side, it must be the left of the tree, and the right side of the 3, it must be the must be the right side of the tree. So it means at least we can write some code. Yeah. Now let's go back. So for the preorder, we don't know yet, but definitely it's gonna be something. But for the inorder, yeah, at the left side, at least we can use this midpoint. So I'm gonna define another midpoint. So this M gonna be like a midpoint. I just need to find where I need to split the tree to the left and the right side. So this midpoint would be, I'm gonna use the inorder node index to use this preorder 0. Yeah. For this 3, I definitely can find the left and the right. So for the inorder, similarly, let me copy these areas. So for the inorder, for the left of the tree, it's gonna be 2m, and for the right of the tree, it's gonna be m plus 1 to the right side, because definitely this 3 is not included. So this is gonna be the inorder. Now we are going to check how to calculate the preorder. if we finish calculating the preorder, definitely we solved the problem. Yeah. Now, this is the left side and this is the right side. The index of this m is 1. Now we're going to use this information to calculate the preorder. Yeah, so definitely the first node will be excluded from the preorder array. It's going to be, the first index is going to be the next index after this index 0. After this 3, it's going to be 9. This is going to be first index. But we need to check what is the distance of the left side or the right side. Definitely we can calculate it. Yeah, we can use different ways to calculate. So maybe the inorder array, the length of the inorder array is L, and we can use this L, it is 5L minus the index I and minus 1. And we can know how many at the left side, how many at the right side. Or we can use another way. So because this index is 1, so we know how many nodes are at the left side. Definitely there is an index 0. It means there's one node. Yeah, there must be one node at the left side. So from here, as we know, the next index is gonna be starting from 1. Yeah. So for the preorder array, it's gonna be starting from 1 to the index this m plus 1, because before it is m. Now we need to exclude the first node, so it's gonna be m plus 1. Yeah. Or we can calculate like this at the left side. So this is I. So if this index is m, so this is the index is m. So this m means how many elements at the left side. Yeah. So for the preorder, if we are starting from 1, it means we're gonna use m plus 1 because m plus 1 is not included. Yeah. Yeah, because we're gonna exclude one node, so it's gonna be 1 to m plus 1. I think it's gonna be this gonna be easy to understand. We just need to calculate how many it is. Before it is 0 to m. This means there are m nodes. Yeah, because it's gonna be from 0 to m minus 1. In total, it's gonna be m node. Now we still need the m node, so it's gonna be 1 to m plus 1. So it's gonna be 1 to something from m. Yeah. Now we can use this calculation to write the preorder of the left side of the tree. It's going to be starting from 1 to m plus 1. And at the right side of the tree for the preorder array, it's going to be m plus 1 to the right. Yeah, because the first node has already been excluded. So here going to be m plus 1. And here we just need to exclude the node at the index m for the inorder array. Yeah. So this is going to be the entire code. If we we don't need to understand the details for the tree traversal problem or the recursive function, but we need to understand the basic constructor, how everything is configured, like how the node is configured, how this m is configured, how can we find this m. This is basically a splitting point, and then we're going to find the left and right. So if everything is right, basically, for the tree structure, it's going to be use the recursive function to make it smaller and smaller until the array, preorder array is empty. If this array is empty, we're going to return a none. Now let me run it to check if it works. Yeah, I needed to put it inside. I needed to use this preorder and inorder array for the DFS function. Yeah, now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed and it's pretty fast. Now let's analyze a little bit about the time complexity. The preorder length and inorder length is 3000. Yeah, if it is a normal DFS, the time complexity would be O(n). Yeah, but we used two arrays, and we used this inorder.index to find the first node. Yeah, if we use it basically for each of the step. For example, for the first step, it maybe the length gonna be yeah, gonna be the whole array, and then we split it and find again. Yeah, so I think maximum the time complexity would be O(n) square. Yeah, because definitely this in order dot index for each of the recursive function, it's gonna have take time. If there's no this line, it's gonna be O(n), but if we add this line, it's gonna consume the time to find where it is. Yeah, so for example, if there is a very long array, if we find the first node, it is here, and then we're gonna use this InOrder.index inside of the array. We need to find where it is. Yeah, and then we have another two arrays, and we still use this one to find where it is. Yeah, and we're gonna split it still. It's gonna be like this. Yeah, but definitely this InOrder array, yeah, this line of code would check all of them, and basically we need to check how many. Maybe this is a and this is a so yeah, and how deep is the tree? It's gonna be log n. Yeah, maybe it is n log n time. Yeah, I'm not sure about the time complexity. If it is not n square, it should be n log n time. Yeah, so for each of the yeah, but this is yeah, for the best case it's gonna be n log n, but if it is not split like that, maybe for each time this is a very long array, after that it's gonna be like this. Yeah, after that it's gonna be like this. So I think for the big O notation it should be O(n) square for the time complexity. Yeah, maybe it is wrong. I'll check it. Thank you for watching. See you next time.